Hey everybody, this is Larry. This is day 17 of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, increasing order search tree. So I only have about 20 minutes to the actual Leetcode contest, so I'm going to probably rush this a little bit. So let's say given a root of a binary search tree, rearrange the tree in order. Let's see. Don't need about 100 nodes. But here, to be honest, I'm trying to think whether we can do it in O of 1 space. We certainly can do this in O of n space in a couple of ways. You can, have an array and then just do it like in order, and then you can create, because essentially this looks like it's just creating a linked list of the in order values. So you can definitely do it that way. And you certainly, so you can do an in order and then you could convert all the nodes, or you could do it that way. But then that's always gonna be O of n space. I'm not gonna lie, we're a little bit in a hurry otherwise, because I feel like I'm gonna mess this up otherwise. Because basically you want to have a function that gets the rightmost node, and then that node will be pointing at itself. But then what will point it at that one? I don't know. Okay, I'm not gonna lie, I'm gonna cheat for today. It is easy, and space is only 100. So I think if you're on an interview, honestly, I would say, okay, n is 100. Yeah, we don't want to prematurely optimize. We have enough space. Let's just make it O of n. But maybe we can probably do it in O of 1. Okay. So let's do that for now, but only because I want to make sure I have time for the contest, because I feel like we can probably do it in O of 1 space. Is that even true? No, I mean, because if we do it recursively, we need O of h space anyway. For the the recursive core stack. So yeah, so maybe that's fine. I don't know. Feel a little bit yucky about it, but essentially we're having a linked list but with a tree node. So let's do it. Let's just do it that way. I'm gonna do it recursively with. Yeah, let's do it that way. Yeah. Let's have a sentinel node. I know that I always call it like new root or something, but I've been trying to be a little bit better about that. And then now we just have a regular in order traversal. So if node is return, otherwise in order node dot left, do something, and then in order node dot right. This is obviously regular in order. And then here we write, okay. Or last tail, maybe. Again, we're using the node like a linked list. So then now we do tail dot right is you go to node. Want to do it that way? Oh, sorry. Okay. I think this. I just thought about this space analysis, and actually maybe I'm lying on this. O of n is gonna be O of h. So yeah, I guess it is what it is. Okay. Is it gonna tell that right? And we have to make sure that tell that left is none. Yeah, I think this is right. I could be wrong. I could have an off by 1 or something. Oh, I'm just trying to make sure that I do these in the right order so that it doesn't get impacted or something. But I think this should be good. Let's run it real quickly and then see if I'm right or I'm just lying. Okay. Or like just wrong, not lying. I mean, if I knew I was right or if I knew I was wrong, I would just say it. But yeah, Cool. That looks okay. So let's give it a submit. I've done it twice before. I wonder how I did it previously. Oh no! I I messed up very easy today. Wow! Yikes! Did I not clean everything? That's the only reason how. Huh? 1, 2, 3, 4. What is? Wow! Yikes! This is what happens when I'm trying to reuse memory. If I just create a new node, this would definitely work. But I tell that right is equal to no. Maybe I think I'm not setting things. Is okay. So now that I'm here, tell that where is it going to none? Maybe that's what I need. Maybe actually. Oh, cyclone tree node. Yeah, this is wrong because I'm cropping it off before because we're recursing on the node, and that's the part that I was worried about when I said before, like when I had like on here. That's what I was worrying about. It is because we're doing a recursion on this node while modifying this node. So, all right. There's probably a clean way to Can I do it afterwards? Huh. How do I find what is 1, 2, 4, 3? Let's see. I'm just writing it out real quick. Wow, today is. Hopefully, I'm getting this wrong answer for today and not for later. But, huh. I mean, I know how to solve this. I'm just trying to think how to do it within the same space constraint. Because definitely for 3 problems, I have a way of writing it during contest but I guess this is great practice then, right? 1, 2, 3, 4. What am I returning? Okay, so then here let's print it out the sentinel. Hopefully every step of the way. Yeah, there should be some cycles until we get to the very end. Maybe that's okay. So this is good after 3, and then after 4. Where's the 4? Oh, because we go back. Because it's parsing the left first, that's fine. And then now the tail. That's so weird. So the tail was 3, presumably. Maybe my recursion is just weird. Oh, whoops. Comment it here. Alright, we have about 10 minutes before the contest, so this is good to maybe get out of the way, maybe. Okay. Yeah, the tail is 3. So then why is it wrong to... Because that node... So now we do a recursion, and now we're at the 4, right? So, except for that we go to here right after we go to the 4. Tail that right as you go to node. So, okay. Tail that left as you go to none. And so the current tail that left is not the current tail dot left is equal to the tail node is 3. Is the non-local thing like am I doing that wrong? I'm trying to think. It's possible that non-local. This is why global things are always a little bit tricky, because this thing. I wonder if this. So I do this thing to move to the next node, but I wonder if this thing like I wonder if there was some timing thing where on the 4, like if you draw the tree, and I could show the tree real quick. I think maybe it's because when I'm at the 4, it already set up the tail variable, maybe, and therefore the tail is still pointing at the 3, and it has some like weirdness about that. Let's see if that's true. I mean, I don't know how to show it though. Yeah, so this is the tail. So tail dot right, we set it to node. Right? Yeah, so that looks okay. Although tree dot node, yeah, I mean we knew that. Oh wait, what? I didn't finish writing it. That's a little bit awkward actually. Okay, so that's good. Is that good though? I thought I had this. Didn't I have this? Okay, let's give it submit again, and hopefully this is good. Okay, so I just had a silly These things are very tricky when you're trying to reuse memory, and that's why, especially in competitive, you know, there's no benefit versus O of H space versus O of N space in competitive. Obviously, in an interview, O of H is O of height, and O of N is linear, and that's just better, right? For type O of H, and that's what I have here. The reason is because we're reusing the existing inputs data, so in place, if you will, to convert these nodes with an O of H height space for the inorderness, for the recursive stacks, core stack. So this is going to be O of H space. Yeah, and this is always going to be O of N time, just to be clear. We're talking about the space optimization because yeah, it's always going to be linear because you have to look at every node, right, no matter what. Yeah, that's pretty much all I have for this one. It's a little bit yikes. Linear time, O of H space, and yeah, I'm just going to take a quick look to see what I did in the past. Oh, I did do it, and this is the way that I was going to do it, but I think this would take me too long to come up with. Just doing the leftmost and rightmost and then just like play around the node. This is also O of N. You could probably find that video, by the way, but this is also O of N time and O of H space. And yeah, and you can kind of play around. This is actually more beautiful if you ask me, because we don't have to use this pseudo global thing, but I was worried about timing. And on this one, yeah, this one we did the hack with the array, which, you know, so we've done it all ways. But yeah, all right, I really got to run, obviously, because the contest is starting soon. So yeah, stay good, stay healthy, to good mental health. Happy holidays for everybody. I forgot about it, but you should, okay. Take care. Bye bye.